Hello, we're Team 2, the sleep-deprived engineers, and this video is a brief overview of our engineering design process for our first year Engineering Design Day project. Our team was assigned the task of designing, building, and presenting a fully functional and unique mechanical arcade game. With the long list of requirements, a lot of ideas, and not a lot of time, a large part of the success we had came down to asking the right questions. This began with weekly group meetings where we were able to openly discuss and brainstorm potential ideas we want to pursue. And we ended up settling on a soccer-themed projectile shooter where the main objective of the game was to score as many goals as possible in a preset amount of time. One of the requirements of our FED project was to write a research paper summarizing the history of mechanical arcade games. Through the completion of this assignment, our team was able to refine our idea and gain insight into the general mechanics we might be able to implement into our game. The milestone documents and Gantt charts we produced throughout the semester were also vital in tracking our ideas, progress, and changes throughout the engineering process. This requirement forced us to constantly ask each other questions and communicate efficiently, allowing the project to evolve, adapt, and overcome the challenges that we encountered along the way. Next up is Rahul to delve further into the imagination process.
So, once we knew our teams and understood the requirements of the project, we created a Discord group and set up rooms at DHL Library to meet up. During the first few weeks of the semester, we had multiple meetings to brainstorm and finalize on which ideas we wanted to implement. The general concept we came up with was a soccer-themed game where the player shoots balls into a goal past moving defenders. Based on the criteria, we generated a final idea for the game. Firstly, for the general structure, we decided to go with the maximum dimensions allowed by the project criteria, which was 2 feet wide, 3 feet in length, and 2 feet tall. To shoot the ball, we designed a spring-powered launcher that could also be rotated with human power. The players move side to side across the playing field via a mechanism that is powered by a DC motor. As the motor spins, the mechanism converts the rotational motion into reciprocating linear motion, moving the players side to side. The ball would be returned to the player with a reload system powered by gravity, which is generated by the inclined playing field. To keep track of the player's score, we decided to program a microcontroller to be able to detect when a player scores a goal and keep track of the goals they score in a set amount of time. We realized that during this step of the design cycle, effective communication was key to make sure our team's meetings were productive and also helped us make significant progress after each of our meetings. Here is Spencer to go over how we made our plan based off these ideas.
Based on our ideas, we started to plan how our project would actually function. We used SolidWorks to model the solid bodies and mechanical aspects, and Tinkercad to map out the circuits and electronics. For the mechanism that moves the defenders, we devised a system in which a motor drives a spinning shaft with a rotating bearing attached to the end. The bearing rests inside a yoke-like mechanism part that can freely move side to side, but not up and down. This converts the rotational motion of the motor to reciprocating linear motion, allowing the defenders to move side to side. To return the ball to the player, we designed a cardboard track that carries the ball to the player if they get the ball into the goal. If they miss, the geometry of the game's body directs the ball into a hole that connects to the cardboard track. To keep track of the player's score, we devised a circuit consisting of an Arduino, a motion sensor, and an LCD display. The motion sensor was rigged to the reload track so that when the player scores, it detects the moving ball and sends a signal to the Arduino. The Arduino displays the player's score on the LCD screen and continues to update the score until 45 seconds have elapsed, at which point it displays a game over message along with the player's final score. At this point, we also started gathering our materials. These included wood for the main body, PVC pipe for the launcher, and various electronic components. We salvaged many of our materials, such as the wood and most electronics, and the rest we ordered online. We also planned out how each component would be fabricated, such as hand cutting, 3D printing, and laser cutting. Additionally, we planned out our timeline for construction. We determined what we wanted completed by certain dates and who was responsible for what.
Once everything was planned, we began the building process. Most of the building process occurred in the makerspace, except most of the wood cutting and the launcher. The makerspace was essential for us to complete our construction as it provided us with almost all the tools we needed to build in the arcade game. We used it to 3D print mounts for the motors and the launchers, which we designed in SolidWorks. We use the hand saws for cuts. We use electronics from the makerspace for the motors and sensors, and paint to make the game. Unfortunately, we did face multiple setbacks, such as there was no powered saws and other power tools, which just made the process a lot slower. There was not enough space. We had a big project. A lot of people were cramming, especially in the last 2 weeks. And a big cut of our wood was stolen, which slowed us down a ton. Granted, some of these issues were in part because we maxed out the dimensions, which we kind of regret. We could not get an appointment to laser cut our wood for weeks at the library, so we used the facility in Centennial campus to laser cut the gear system. That made our goalies move from side to side. Overall, this university provided us with a lot of the resources to complete our project, but we did use outside resources such as powered saws. We got a lot of the wood for free, or we reused a lot of wood from other sources, and we also created the launcher outside of campus as it was just easier. I'll now pass it to Eswar.
If we had the chance to redo the project, we would do many things differently. One of the major problems we encountered was with the arcade game's portability. At the start of the planning stage, we were under the impression that maxing out the dimensions was a good idea, but in hindsight, it turned out to be a terrible decision. We also felt that our timeline was a little too unrealistic and would definitely make efforts to make a more reasonable one next time around. We would also advise to devote more time to testing the final project, as we ran into a last-minute issue where the motion sensor would sometimes not sense projectiles if they were shot back-to-back. We would also like to emphasize the importance of beginning work on the project before spring break. As we started construction quite late, we cut it really close to the deadline. And lastly and most importantly, remember to have fun.